We have come to the last lesson of this topic on equilibria. It is not really anything very original because it's a compilation of concepts and of course equations that you have learned from previous lessons. This lesson is about the solubility product. What is this fancy term? This fancy term is actually an equilibrium expression, KSP, for what exactly? For a salt that is sparingly soluble. Take for example the salt calcium hydroxide, silver chloride, and barium sulfate. We tend to know these compounds as precipitates that form when doing qualitative analysis, but they are not completely insoluble. A tiny little bit does actually get into the solution. How much is this tiny little bit? You will find out in a while. By studying the solubility product, we will be better able to dissolve these largely insoluble salts, which can be really useful in certain fields of science. Now, do not confuse solubility with the solubility product. They are different things. Solubility describes the amount of salt that is dissolved in water, while the solubility product is an equilibrium constant for the dissolution of the salts. Let's take, for example, calcium fluoride. Let us write the equation for the reaction and expression for the dissociation. As shown here, this is just like a normal equilibrium calculation. A key point to note here is, however, the reactant is probably not in aqueous forms like the products because of the high insolubility of it, and it stays as a solid. We do not factor in the concentration of solids, hence the expression has no denominator, which explains why it looks like a product. Calculating KSP is simple. At equilibrium, when the dissolution has reached its maximum, all you need to do is plug the concentrations of the ions into the equilibrium expression and raise them to the relevant coefficients, of course. How do we get the solubility from the solubility product though? Say we know that the KSP for calcium fluoride is 3.9 times 10 to the power of negative 11 at 25 degrees Celsius. We don't know how much Ca2 plus or F minus there is going to be. Let us use the unknown X to represent the concentration of Ca2 plus. Stoichiometrically, the concentration of F minus must be twice that of Ca2 plus, so 2x on the other side. So multiplying together, we get 4x cubed, which we can then solve for x, giving us 2.14 times 10 to the power of negative 4 molar. And this is x, the concentration of Ca2 plus. If I assume there was 1 liter of solution, then I would have 2.14 times 10 to the power of negative 4 moles of Ca2 plus, which could only have come from the same amount of CaF2. Take the molar mass of CaF2, multiply that by the number of moles to get the mass of CaF2 dissolved. And finally, take this mass and divide it by the volume to get the solubility in grams per liter. So that's how you find solubility products, and from there, solubility.